A particle P is moving along the line OX, so that's the x-axis, with an acceleration of 6t minus 18 meters per second squared at time t seconds. When t equals 0, the displacement of P from O is 0, and its speed is 24 meters per second in the direction OX. So we should make a note there that x is equal to 0 and v is equal to 24. If it says direction OX, it means the positive x-axis when t equals 0. We want to find the values of t for which v is 0 and the values of x for those two values of t. So a is equal to 6t minus 18. So to get to v, we're going to integrate that, 6t minus 18 dt. So that's going to be 6t squared over 2, take away 18t plus a constant. Just tidying, that's 3t squared minus 18t plus a constant. And then we can use the fact that v is 24 when t equals 0. So 24 is going to be 0, take away 0, add c, which means that c is 24. So v is going to be 3t squared minus 18t plus 24. So if v is equal to 0, that means that 3t squared minus 18t plus 24 is equal to 0. Divide through by 3. T squared minus 6t, so we divided by 3 plus 8 equals 0. And we can factorize this. So t and t is going to be 4 and 2, minus and minus. So t equals 4, or t equals 2. So now we need to move on to x. So x is going to be the integral of v. So that's the integral of 3t squared minus 18t plus 24 dt. So that's going to be 3t cubed over 3, so just t cubed. Take away 18t squared over 2, so that's take away 9t squared, add 24t plus a constant. We're given that x is 0 when t equals 0, so 0 equals 0 take 0 plus c, which means that c is 0. So we now have that x is t cubed minus 9t squared plus 24t. We want x of 2 and we want x of 4. So let's just bring the calculator in. So we've got 2 cubed minus 9 times 2 squared, add 24 times 2, and that gives us 20. And then for 4, that's going to be 4 cubed, take away 9 times 4 squared, add 24 times 4, and that gives me 16 meters. We want to find the distance travelled in the first 3 seconds in part B. So we know, let's just put ourselves on an axis like this, and if this is O, we know it's here at t equals 0. We know the velocity is 0 when x is 2. We found that over here. And when t equals 2, we know that it's 20 meters here. So it's travelled like this. Now, x of 4 is 16, so it follows that it starts to travel back this way. And we want to know where it is when t is 3. So what we're going to do is calculate x of 3. So let's just substitute 3 into here. So it's going to be 3 there, it's going to be a 3 there, and it's going to be a 3 there. And that puts us at 18. So the distance travelled, it's gone out here to 20, and then it's come back another 2. So it's travelled 20 plus 2, so x of 3 was 18 meters, and then the distance travelled is 22 meters. Now I quite like to reason these out the way I've done here with the diagram, but you can do this on the calculator. Now I'll just clear everything that's here, just so that it's much clearer what we're doing. So I'm going to start by doing an integral, and I'm going to go from 0 to 3, and what I want to put in here is the velocity. So the velocity function, if we can find it on here, there it is. So I'm going to use x rather than t. So 3x squared minus 18x plus 24 dx. Now note that that doesn't give us 22. Just like with area, it's given us 20 and then it's taken the 2 off because it comes in a different direction. So if we just instead put this in a modulus, that will give us the 22. So you can do the modulus because what that does is it takes this 2 meters in the opposite direction and just points it back positive, and then we get 20 plus 2, just as it does with area.